Now, folks, we are going to be graphing a three-piece function. Now, you might be thinking, man, this is too much. I can't do it. Remember, it's just one piece at a time. It's no different than a two-piece function other than it has another piece. Same steps. So here's our first piece. F of x equals x minus 5 whenever x is less than negative 3. Second piece. F of x is equal to negative 2 to the negative x. It's exponential. Whenever x is greater than negative 3 but less than 2. So in between these two numbers. And finally, my third piece, f of x is equal to 1/2 x squared quadratic function whenever x is bigger than 2. So you've got these three intervals. X is less than negative 3, x is bigger than negative 3 but less than 2, and x is bigger than 2. And that actually covers the entire domain. So we'll take a look at that. Step 1 is to graph the first piece. My first piece is up here at the top. So again, you're going to take this interval number and plug it into that piece. Negative 3 minus 5 is negative 8, but because this is less than and there's no bar, there's going to be a hole there at negative 3, negative 8. Now I need to choose at least one point that's less than negative 3. In fact, I only need 1 point because this is a line because it's x minus 5. So I'll just choose negative 4. I'm going to plug in negative 4 into my top piece and get negative 9 back. I'm going to have a solid point at negative 4, negative 9 because negative 4 is part of my interval because it's less than negative 3. So for right now, here's my hole at negative 3, negative 8 that I figured out there. Then I have my point at negative 4, negative 9. It's a solid point. I'm going to connect them with a line, and I'm going to keep going forever like a ray, but it will not go through the hole because it's a hole. So that's my top piece. Let's get to the second piece, negative 2 to the negative x. I'm going to have to plug in both these numbers in there because they're part of the interval. So let's plug in negative 3. We get negative 2 to the negative 3, lots of negatives. Negative 3 is positive 3, but it's negative again, so it's negative 8. Now, this is a bar here at the negative 3, so that will be a solid point at negative 3, negative 8. Okay, next up, I'm going to be plugging in my other x value in my interval, which is positive 2, and then I'll plug in some numbers in between after that. So we get negative 2 to the negative 2. Now, 2 to the negative 2 is 1/4, because it's 1 over 2 squared. And final answer then is negative 1/4. Now, because there's no bar there, there's going to be a hole there at 2 comma negative 1/4. So keep that in mind. Now let's do some numbers in between. So we'll start with negative 2 because that's in between negative 3 and 2. We get negative 2 squared, which is negative 4. So at negative 2, negative 4, we're going to have a solid point because negative 2 is in between these numbers. Let's plug in negative 1. We get negative 2 to the first, which is negative 2. Negative 1 is in between these numbers, so it's part of the interval, so it's going to be solid at negative 1 comma negative 2. And I think I did one more. I plugged in 0. I think I went really overboard here. 2 to the 0 is 1, so you get negative 1 back. So you're going to have a point at 0, negative 1, which is also solid. And I also chose positive 1. So wow, I just chose every integer between these two, including both of them. We plug in positive 1 and we get negative 2 to the negative 1, which is negative 1/2. So at 1, negative 1/2, we're going to have a solid point. So here's my, is this my second piece? Yeah, I wasn't able to, I have a disjointed connection here. Let me see if I can fix that. Okay, so here's the thing. At negative 3, negative 8, we had a hole for our first piece, right? We got it from here. But when we plugged in at negative 3, negative 8 into our second piece, it's solid. So it will actually fill that hole. Okay, and I did go ahead and connect those points that I just figured out for my second piece, the exponential, and make them a little bit more unified. And then, of course, at 2 comma 0, we already determined that is a hole because it's not part of the interval. So far, we have these two pieces graphed together. I guess I could make that a little bit bigger. Let's see if I can fix that. Okay, there we go, much better. So far it looks like this. Kind of looks like a person doing an exercise or something to me. But anyway, the graphs aren't always going to look perfect, okay? They're not always going to, sometimes they're just going to look weird, especially piecewise functions. Okay, let's get to step 3, graphing the third piece. The third piece of our function was 1/2 x squared for x is bigger than 2. We're going to plug in this number into our function. However, it's not part of the interval, so it's going to be a hole because there's no bar here. 2 squared is 4, half of 4 is 2, so there will be a hole at 2 comma 2 for our third piece. Now it is quadratic, so we know it's going to be parabolic in nature. Let's plug in a bigger number than 2, 3. 3 squared is 9. 1 half of 9 is 4.5. Since 3 is bigger than 2, it's going to be part of our interval, so 3 comma 4.5 will be a solid point. And you could keep going and plug in 4, 5, and 6. If you plug in, for example, if you plug in 4, you get 8. So go ahead and help yourself do it. I just did 1 because I know it's going to go to the right and it's going to be U-shaped. Again, you could put a point here at 4 comma 8. However, there is a hole at 2 comma 2, and then there's a solid point at 3 comma let me make sure here, 3 comma 4.5, and I know it's going to be U-shaped, so I'm just going to draw a curve going up that way. Notice they are disjointed here. They don't connect, and that's fine. My middle piece stopped at 2 comma 0, and my new piece started at 2 comma 2, and they're both holes, so what that means is this is not a continuous function. It breaks at 2, and that's fine. It's still a function, though. It still passes the vertical line test. Here's my first piece. Here's my second piece. Here's my third piece. If they don't make a perfect picture, that's fine. That's why it's called a piecewise function. You're taking different pieces of different functions, and you're putting them together. If you have any other questions about this lesson, let me know.